Welcome back to our APES flipped classroom, where we're continuing our conversation about ecosystems. And today we're focusing in on ecosystems and their energy and where that energy comes from and how it's used. And so we broadly call that primary productivity. And so we're going to jump right in and talk about primary productivity. So let's look at the basics of primary productivity. So when we talk about primary productivity, what we're really talking about is the rate at which solar energy is converted into organic compounds using photosynthesis over a period of time. So primary productivity is going to have units that are in usually kilocalories per square meter per year. You may see it in calories per square meter per month or per day. The units can potentially change, but it is usually in units of energy per square meter per year. You will also see it in units of grams or kilograms of carbon per square meter per year, because that's another way of measuring those amounts of organic compounds. So we have a lot of different ways of expressing it, but it's important to recognize that when we talk about productivity, we're always talking about it per unit area, per unit time. And so when we compare different ecosystems and different biomes and their productivity, it's important to recognize that we are talking about per unit area, per unit time. So our first unit addresses energy, our second unit addresses area, and our third unit addresses time. So another way of looking at this is that it's a measurement of the rate of photosynthesis from all the producers in an area over that unit of time. And since photosynthesis leads to plant growth, we can also think of primary productivity as the amount of plant growth in an area over a given period of time. And that's where we come into measuring that grams or kilograms of carbon. If we have high primary productivity, we're going to have lots of plant growth, which means we're going to have lots of food and shelter for animals. So that means that ecosystems with high primary productivity are usually more biodiverse. That means that they have a higher diversity of species, higher number, better distribution than ecosystems that have low primary productivity. So how do we calculate primary productivity? So we know that some of what the plants take in using photosynthesis, they're actually going to use for their cellular functions. So they're going to do cellular respiration. They're going to free up some of that glucose that they've stored in photosynthesis, whether that's for movement, for internal transportation. So we do lose some of our primary productivity to respiration. So these are the expenses that the plant needs to pay. So we'll talk about gross primary productivity, and gross primary productivity is the total amount of solar energy that plants capture and convert via photosynthesis to energy or glucose. So this is the total paycheck that the plant earns. Net primary productivity is the amount of energy that's left over for the consumers after the plants have used some of that gross primary productivity for their own purposes. And so we can think of net primary productivity as the actual amount of the plant's paycheck it can save after it pays out those expenses. So the plants take in a certain amount of energy, they use some of that energy, and the rest of it they can store. And the amount they take in is gross primary productivity, the amount they use is respiration, and the amount they store is net primary productivity. So we have this equation: net primary productivity is equal to gross primary productivity minus respiration. So one more time. GPP is the total energy that's captured, then some is lost to respiration, some of it is stored and is left over after respiration, and we call that part net primary productivity. Okay, so when we look at efficiency, the sun provides many kilocalories of energy to our planet every year. but only 1% of the energy that actually hits leaves is captured by photosynthesis. 1%. 99% of that solar energy is reflected or passes through our producers without being absorbed. Of that 1% that's absorbed, only 40% of that supports the growth and reproduction of the producers, and 60% of it is lost to respiration. So 1% of incoming sunlight is captured, only 40% is converted into biomass or plant growth. That's that NPP, that net primary productivity. So 0.4% of our total incoming sunlight that strikes the plant, that's not even counting the sunlight that doesn't strike the plant, but 0.4% of the total incoming solar energy gets converted into biomass. Some ecosystems are more efficient than others. They're going to have a higher net primary productivity. And that really just has to do with the individual plants that exist there. So let's talk about why some ecosystems are more efficient or have a higher net primary productivity than others. The more productive a biome is, the wider the diversity of the animal life it can support. We talked about that at the beginning. So I want you guys to think about the most productive and the least productive terrestrial and aquatic biomes. So here are our biomes. I've arranged them a little bit differently rather than terrestrial and aquatic. We have our marine ecosystems and then our continental ecosystems. So you'll notice that swamps and marshes, as well as lakes and streams, are both falling in here on the continental ecosystems, even though they're aquatic biomes. And you'll notice, I think, that the most productive continental ecosystems are those swamps and marshes and tropical rainforests. And the most productive marine ecosystems are coral reefs and salt marshes. And why is that? Well, you have lots of water availability, you have high temperatures, and you have high nutrient availability. If we think about the coral reefs and the salt marshes, those are shallow waterways. There's lots and lots of sunlight penetration. So we have lots of solar energy coming in. You also have high temperatures, which means that it's going to be, that energy is going to be available. You have lots of nutrients, and the same thing with swamps, marshes, and tropical rainforests. Now, if we look at the shortage of any of those factors, we're going to have lower net primary productivity. So when we think about the desert, it has extremely low water availability and very low nutrients. When we think about the tundra, it has very low temperatures and very little liquid water. And when we think about the open ocean, it has very low nutrient availability. So I want you guys to think about the open ocean when we think about net primary productivity. So although the open ocean has very low net primary productivity in terms of grams of carbon or kilocalories per square meter per year, this is where I said that per unit area, per unit time is really important. Because although the open ocean has very low net primary productivity, it has extremely high overall productivity because of this per meter squared. 70% of our globe is covered in oceans. And so there are billions of square meters of ocean. And so even though it's low per unit area, because there is such a high overall area, the ocean is a very overall productive. But when we talk about net primary productivity and gross primary productivity, because they are measured per unit area, it's important to recognize that per unit area, it's very low. Okay, and that's it for today. As always, if you have any questions, please make a note and let me know, and I look forward to seeing you soon.